Hello, I'm Brian Levine, and welcome to this session, A Warrior's Journey, Building a Global Application Security Program. Before we get started, just some quick highlights of my background. So these days, I'm Senior Director of Product Security for Axway Software. If you haven't heard of Axway, Axway is an enterprise cloud services provider to Fortune 2000 enterprises and global government customers. My team and I support a global engineering organization with roughly 600 developers in 7 R&D locations and over 150 unique products in our catalog. So my formal education is in industrial engineering. And before getting into security full-time, I held a number of systems engineering positions delivering secure data management and data protection solutions to federal, aerospace, and manufacturing businesses. For fun, I also enjoy practicing jiu-jitsu, and I don't back down from a challenge, even if it's from my niece, the karate master pictured here. So this journey began when I was interviewing for a security product management role at a SaaS startup. During the process, I asked if I could speak to their chief security officer and head of security engineering. And so after a few awkward stares, the effective response was, well, we don't have those yet either, and yeah, we'd like you to handle that for us too. And that's where our story begins, so let's have some fun with it. So I'll start off asking you the question, where would you begin? There's an alphabet of soup of standards to choose from. You've got ISO, SOC 2, OWASP, NIST, BSIMM, PCI, and on and on and on. If you were tasked with building a security program, it was day one in a new role, which playbook would you use? Is there a script you can follow? Which set of frameworks would you use to get started in the right direction? So my talk today is going to draw on this quote and the wisdoms of the martial arts master and philosopher Bruce Lee. Adapt what is useful, reject what is useless, and add what is specifically your own. And so in that spirit, I'm going to draw on my own experience with some of these frameworks and guidelines and cover the core foundational components that I feel have led to my success and I hope will help you get started. And as well as I hope that you'll take some ideas away from this to advance your own application security program. So what I'm hoping you'll get out of this talk are some strategies and tactics that you can use to develop and improve your program, and what we're going to cover in these 3 core areas. So we'll focus on establishing a security culture, we'll look at developing and scaling security processes, and we'll look at governance for ensuring visibility and executive accountability. So I really look forward to hearing your feedback, questions, and maybe some different opinions, other ideas that maybe you've found to be successful. And also I'm going to try to be brief where I can because of the recorded format and attention spans for watching long videos. So I might gloss over some details, but I'll be happy to cover that in more depth or give you more detail if you just ping me and we can follow up offline. So we'll start with culture. Security is everyone's responsibility. You've probably all heard this declaration in some shape or form in your career. But how do we really implement that? Everyone can't do security all of the time. Developers, managers, operations teams, they all have day jobs to do. So let's unpack this a little bit and talk about some of the key role players and what their responsibilities are in delivering a security program. So the first role we're going to take a look at is the Central Application Security Group. This group goes by many names. You may recognize some of these. If you're looking at the OWASP, SAM, they call it the Secure Software Center of Excellence, or the SSCE. It's a mouthful. The BSIMM calls this team the Software Security Group. In my company, Axway, we call ourselves the Product Security Group. I've also worked with individuals who go by Product Security Office. So there's many names, and you may recognize a few. But whatever you choose to call it, let's look at some of the guidance from OWASP, SAM, and BSIM and others on what the roles and responsibilities are for your central security team. So just highlighted in red here, a couple of the ones that I resonate with and have worked well for me. Number one, defining the charter. So make sure that it's defined, written down, and that you've got executive management buy-in and executive sponsorship on the charter. The security group needs to publish SDLC standards and guidelines for app security, and the product champions are typically the ones that are going to be required and responsible to first select the tools to use within the organization for security scanning and the SDLC process. Excuse me. Also, some very interesting data and pointers from BSIM. So if you look at the BSIM study and what they recommend for the SSG, you can read the slide here, but according to their observations, the very first step is to form an SSG. Without an SSG, success is very unlikely. So they looked at 130 firms in the latest study and noted that every single one of them has a security software group. So basically the message is, don't try this at home if you don't have an SSG. Also some interesting data from this study. If you look at the first red arrow there, the average size is 2% of SSG members to developers. So in other words, for every 100 developers, you have 2 members on your SSG team. And then firms with over 500 developers or more, in that group, the largest size of the SSG was 3%. So as a benchmark, somewhere around 1 to 3% of your SSG team to the number of developers seems like the goal to shoot for. And of course, it all depends on the size of your organization, your mission, the business you're in, and the information you're trying to protect. So just some advice and notes on building your Software Security Center of Excellence. Number one, getting started. So securing executive sponsorship is critical. You have to get executive buy-in and executive skin in the game. Believe me, you will need this when it comes time to prioritize security alongside with feature development, product roadmap, and other stakeholders and other challenges to the business. Everyone's got a say in what the development team should work on next. So getting visibility and sponsorship for security at the top down is critical for your success. Additionally, the charter and scope should be written, documented, and shared within the organization on a wiki or the corporate intranet. Make sure this is documented, shared, and everyone has access to it and visibly understands it. Your goals and objectives need to be defined, achievable, and measurable. Assuming you've done the first 3, you want to make sure you're aligned with R&D. So you make sure that they are aligned and in agreement with your scope, your charter, the goals of your SSDLC. If not, iterate, go back again until you have that alignment. Additionally, when you're working with engineering, make sure you understand the procedures and tools they use today. Are they using Agile? Are they doing Scrum? Are they doing continuous integration? What's their product lifecycle look like? What does their roadmap look like? Make sure your security group understands the environment and has that business awareness of the product development lifecycle before you start. And then start with internal evangelism. Again, the blogs, internal wikis, corporate intranet, Slack channels, teams, establishing a forum where you can put out your guidance, put out your guidelines, get discussion going, ask for feedback. These are all important goals to start building a culture and to start evangelizing security. And then also the SSCE is responsible to look at and see what platforms are we using, what languages, what type of vulnerabilities are being discovered, and identify tools to address and identify those types of issues. So those are some points on getting started. Now let's look at if you already have a software security group and you're looking to kind of level up and take things further and improve the program. So number one, stay focused on the customer. R&D is your customer. And as you progress, you need to remember that their needs come first in terms of helping them achieve security in their workflow. You have to align and make it so that they can accomplish their goal of shipping software, and you're serving their need and helping them achieve security in their software delivery. We'll go from the getting started phase to leveling up. Now we're enforcing and publishing SSDLC standards, procedures, and best practices. We're no longer just sharing ideas, but we're enforcing standards. And then as you grow and as the team continues to grow and scale, you want to start identifying promising members of the development organization that have a knack for security, promote them or designate them as security champions, or maybe they might be interested in joining the Security Software Center of Excellence and coming on to the core team. And as you scale, external evangelism becomes a bigger part of the program. So not only are you selling internally, but now you're publicly talking about your program, going to trade shows and giving talks, going to conferences, blog posts, engaging with customers, and doing a lot more outbound public marketing of your security program and the security of your products that you're delivering. And as you scale up, of course, DevSecOps automation, really leveling up requires automation and continuous delivery at DevOps speed. And we'll talk about some of that here today. And then data-driven program management. Again, as you scale to 100, 150, 1,000 products in your catalog, you need to measure the activities, measure what your team is doing, measure the security issues that are being discovered in the products that you're working with, mine that data to improve your product process, to improve your team's workflow, to improve your team's charter. So I'll give you an example. In our company, we looked at defects that were being reported on a certain category of products. And we discovered across all of these products, 25% of the reported issues were third-party component related. So we initiated a program and a procedure to improve our software composition analysis and select some new tools and some better procedures to reduce that specific type of vulnerability. So the next role I'll talk about is the security champion. So the security champion is, here's, you can see what SAM, their definition for security champion, and you can also see some statistics from BSAM. From BSIM. The important thing here is that the security champion is defined for each development team. And 42% of the firms in the BSIM study, 42% of them have a security champions program, and 65% of the firms have a program if they've been part of the BSIM study more than one time. So now we'll look at some specifics on building that security champions program and leveling up the security champions program. You can see also some companies call these security champions, others call it security point of contact, or the SPOC. So you can choose a creative name that works for you. but the idea here is to identify individuals with a passion and an interest for security. Volunteers work a lot better than voluntold. So it's always better to find the folks that are already coming to you asking about security topics, asking about privacy, raising security issues, coming to you with challenges and things to work on already. Those are the folks you want to identify and name as your security champions. What the security champion's main responsibility is to execute the secure development lifecycle procedures, the testing, the threat modeling, the security scanning inside of the development project that they work on. So they're kind of the single point of, or the point of contact for the SSG, as well as the individual on the team who's responsible, hands on the keyboard, for setting up and executing the scans. They'll also work with the DevOps team and others on the team to instrument the tooling, as well as some other activities we'll talk about in the next slide. But triaging the findings that come back from the tooling, getting that into the backlog. In terms of scaling the program, once you're kind of up and running and scaling, now you're looking at multiple full-time champions per project. Some teams and some development teams will have multiple SPOCs. Some will have multiple full-time security champions working on one development project or a set of microservices for one product. Again, as you scale up and mature, your security champions are likely going to be pushing the curve. They're going to be identifying improvements, identifying new procedures, new security tools that you can then leverage back within the SSG and also leverage through other development projects using these tools and advancements. And then also sometimes the security champions, as you evolve, these team members will eventually make their way onto your central secure software team or your software security group, and be core members of the SSG. Some gotchas and some anti-patterns to look out for with SPOCs. Number one is, if your SPOC is the only member of the team responsible for security, then and all security tasks and questions are assigned to the SPOC. Now, the SPOC should be working with DevOps and build managers to prioritize and automate security testing into the pipeline. It is not always the SPOC's responsibility to create the pipeline or create the DevOps tooling to run the scans. The SPOC's responsible to help triage and review the findings and then put them into the backlog, but then the entire development team is responsible to work on that backlog, fixing security issues. Again, the second bullet here, the second anti-pattern is, if the SPOC is responsible to prioritize security into the product delivery cycle. And the third anti-pattern is if there's an adversarial or subordinate relationship between the SSG and the security champion. So for the last two bullets, in terms of responsibilities for priorities, and it's the engineering manager and the product manager and the executives to responsible to prioritize security. It's not the SPOC's role to prioritize security. You don't want to make the SPOC's job harder than it is already by also making them now convince their boss that security is priority. This has to be top-down, driven from the executive top-down. So the executives are responsible to prioritize security. The engineering managers, the product managers are responsible to be aware and have visibility on the security of their product, and they're accountable to make sure security is accomplished within their roadmap, within their delivery cycle. It's not the SPOC's responsibility to prioritize. And as far as the third bullet, again, making sure that your SSG keeps in mind that R&D is the customer, the SPOC is the customer. The SSG is serving the security champion. It's not a blaming culture. If the product is failing security, it's a business, organizational, product management issue. It's not the SPOC's fault. So we want to execute in a blameless culture, in a blameless environment. So now we've established who the role players are. How do we get teams to know and apply what we need them to do? Quote here, knowing is not enough, we must apply. Willing is not enough, we must do. So I'll talk about 3 core components for the education and awareness part of culture. Number 1 is structured training programs. So we've got mandatory developer security training, advanced, role-specific, and platform-specific training, which is a little more hands-on. The mandatory, this is for all developers. When they hire on, they are required to take a training, and then either annually or biannually after that, take a refresher. The advanced blue belt classes, these are for more role-specific, platform-specific, language-specific, where we want to get more hands-on into fixing code and looking at specific problems in the language that they work every day, and do hands-on exercises, hands-on coding challenges related to their day-to-day responsibility. And the black belt is more behavioral achievements and certifications. So this can be hosting a security meetup, writing a security blog post, publishing something internally or externally. These are all behaviors that contribute to someone's achievement of the black belt. And it may take several years to build out a training program and to see a cohort go from white belt to blue belt to black belt. So obviously, if you're just starting out, start with the mandatory developer security training, which will include the top 10 OWASP vulnerabilities, common security mistakes developers make, and spreading that awareness around common challenges. The third bucket here on the slide is security events. These are kind of security days where we do a workshop day. We'll have someone from the SSG go into the site, R&D site, or within a team, and do some immersion. Usually we'll do some structured training and then do some tournament or challenges. We also use capture the flags. This is a great way to, again, bring people together in a fun way. It's hands-on, it's fun, and gets people interacting and really kind of seeing some real-world challenges, either on sort of the capture the flag type of targets, or even setting up challenges where they get to attack and hack into their own products. Just mention here, we use OWASP Security Shepherd as one of the tools we use for capture the flags, and there's a lot of other great tools out there, open source and commercial, you can use here. And then finally, the third part is the recognitions and rewards. We really want to reward and praise people for taking the initiative and for taking advantage of the training available to them and going the extra mile as needed in their products and across these challenges. So, publicly praising them in Slack, Teams, company intranet. You can launch a Security Stars program where, again, you, on a periodic basis, either quarterly or monthly or just ad hoc, name who the Security Stars are for that time period and announce them publicly. And also, of course, a little swag and some inexpensive gift cards can go a long way. So this is a fun and engaging way to kind of breed awareness and brand your application security program, have t-shirts made, come up with a logo for your team, and share those as awards. And also, of course, hit up your vendors. They're a great resource for hoodies, stickers, and other fun giveaways. So now we're going to move into the second area we talked about and highlight some of the processes and technologies needed at the foundation level and also what's needed to advance your program. So the first step is to define your security gates and passing criteria. And I just highlighted, this is from the Microsoft SDL, but I'm highlighting here kind of three areas we're gonna focus on at this point. So establishing security requirements. The idea here is this is the optimal time to define the requirements as upfront during the initial planning phases of the product. And we want to integrate security in a way that it doesn't disrupt delivery and the life cycle of the product. So letting the team know upfront, as far in advance when they start developing this project, what are the security requirements, what are the security bars, what does the development team need to do in order to achieve a passing grade on your security requirement. And so this is really important to document this. It's really important to meet with the teams and go over the security requirements so that everyone knows what they are. It builds trust in the program. It improves understanding. Lets us reduce friction and frustration at the end of the process. No one likes surprises. Engineering will be frustrated and lose goodwill if requirements are constantly moving or not well defined. And so here in a typical SDL, we would define our requirements. In the requirements phase, the development team executes the procedures, and then when we get to the release phase, then we'll have a final security review, or FSR, where we check and verify that the team has hit the requirements that were agreed to at the start of the project. So this next pro tip draws some inspiration from these words from Bruce Lee again. Be shapeless, formless like water. Water can flow or water can crash. Be water. And what does that mean with respect to our security program? Well, what this means is you want to merge your security into the existing development cycle. First, you identify the gates and collect the results, but don't enforce them yet. You want to flow into the process like water. You're not here to cause a team and development crash at this stage. You want to show up, observe the security posture of the product, observe what the team is doing, and adapt your security requirements to the tools and instruments that are in place and already in use by the developers. And so both of these statements come from the BSIM. So defining checks, but without enforcing them is also a tip from BSIM. And so again, what this means is that we're going to define the security metrics, the security criteria we want to look at. We could decide which points in the process we should be doing these security requirements, but we will not start enforcing them straight out of the gate. We'll just observe, and then when the team gets comfortable with the tools, when the team gets comfortable with the metrics, then we'll choose an agreed upon timeline to then start enforcing them and making them mandatory. But first, just observe. And so for security gates and defining security bars and security requirements, I'm just going to give an example here. Here's what one security gate might look like for one control. So software component analysis. So for software component analysis, for ISR and FSR, the project is scanned using the approved SCA tools. All results are reviewed by the development team. And then assuming we're doing enforcement now, all critical, high, and medium issues are resolved prior to the release. Again, doesn't have to be extremely verbose, just something that's clear, concrete, measurable. You can put it in writing to the development team. They can see exactly what the requirement is. They know how to measure it, and they know how to know if they've achieved and passed the security bar. And so in practice, you'll follow kind of a pattern like this on the other security gates or security bars you need for your environment. So for example, we have bars for threat modeling, secure design review, static application testing, container analysis, attack surface analysis, and dynamic scanning. Each of these controls will have a security bar definition that says how do you test this, how do you measure it, and what's the passing criteria for that bar. Now in the process section here, so far we've covered the foundational aspects to defining your SDLC process. Now we'll take a look at what this looks like at scale in a DevOps world, keeping pace with continuous delivery, continuous deployment, and continuous security. So I like this quote from Bruce Lee here: "I fear not who has practiced 10,000 kicks, but I fear the one who has practiced one kick 10,000 times." So that 10,000 times is what we're talking about here now, is that the SDLC is great, but how do you do that 10,000 times? How do you do 100 releases per week or per day if needed and still meet your security requirements? So that's kind of the subject now. We're going to move into more of an advanced SDLC at scale. Now we're talking about continuous security and DevSecOps. So we'll go through all of the details on this slide, but the point here is that in today's DevOps lifecycle, where we have frequent small changes, your MVP, hot fixes, minor changes, etc., all going out, multiple deployments sometimes per day, there isn't enough time to perform 100% of the manual security tests and sometimes the automated security tests on every single change and release to production. So how do we overcome that and scale security requirements to DevOps speed and scale? There's no longer a shift left. As you can see, there is no left. It's a shift everywhere. So now security is ingrained in every step of the DevOps lifecycle. So here's a notional example of what a continuous security pipeline at scale would kind of look like. Obviously, it requires a high level of automation and orchestration. And again, this is just an example. There's some vendor names and examples here on this slide. Again, these are just notional examples. They are not meant to endorse any of these vendors. Just some examples of some that we've seen. So here, what we're illustrating is that security is integrated into the CI pipeline. And security monitoring is integrated into operations, telemetry, and procedures. Defect management is centralized, backlog management is centralized, and it's all integrated. And we want to use the same systems that the engineers use every single day to do their work. That's where we want the security information and the security tasks, security defects, all entered into that same information that the engineers are looking at every day. Security can't be something that happens on the side or at the end and dropping off a report to someone to now go look through a document to figure out what needs to be done. The security tooling is integrated directly into the engineering and development pipeline. So we'll kind of just quickly go through this example here. We won't spend too much time on it. Again, if you want more details about this or the previous slide, ping me and I'll be happy to share more depth. But in this example, you can see that security tests are done before deploying to staging. Once we deploy to stage, we run the dynamic testing and surface analysis testing. If it passes those tests, then we can deploy to production. And for out-of-band tests that don't happen during the pipeline, we check via APIs to see the latest result from those tools. For example, in threat modeling, you can check and see, has this product or feature had a threat model, and if so, are there any open or outstanding issues that were raised from that threat model that haven't been addressed yet? So another quick example before we move on, highlighted on that last slide what a kind of end-to-end security automation framework looks like. And we're going to take a kind of deeper look into an actual CI/CD pipeline with security built in. The point and example here is, developers want pipelines that run fast. They want fast build time, and they want immediate feedback. The problem with that is some security tests cannot be done on every single build. So what a CI pipeline like this would do is, on the test that can be run directly in the pipeline, so for example, dependency check for composition analysis and twist lock for container scan, they will be run in line. Anything that happens either maybe on a weekly basis or is a manual process, they will just go and fetch the latest result from that job. And then as long as everything passes, then the build passes and the pipeline passes, and they can move on to the next stage. So now we've come to the third and final stop on our tour, and appreciate your patience and attention so far. I'm going to cover two core components on governance, and then we'll wrap up. So the first concept we're going to talk about is establishing a meaningful metric and KPIs. And the second point we'll talk about is handling security exceptions and risk acceptance as part of your SDLC process. So in this example, I'm sharing some KPI metrics and dashboards. In this example I'm showing, we have a aggregated risk score, and this risk level is determined by an aggregation of all the components included in this product. You can see kind of by product, but then also by component, what the score is. And then this score is made up of the individual results of the various security scans and security requirements for that component. So one of the really important point I'm trying to illustrate here is that, number one, you want to aggregate this information, you want to aggregate the metrics, and use these to communicate risk to the business. You want to share this at the executive level so that they, see trends and they're aware of the current security posture. You also want to use this, share it across all of R&D, so every team can see how they're doing relative to other areas of the business. Measure your trends and then use those trends to improve your program. So the next point related to governance is around accountability. So we talked about the SDLC process and how the product and engineering projects have to achieve a pass in the security bar to move forward. We kind of touched on what happens if a product doesn't meet the security gate, and that's what we're talking about here. So remember, at the end, the goal is to release software and get our valuable products out into the customer's hands. We don't live in an ideal world where every engineering project is going to meet every requirement on every release, whether we're talking about quality, feature development, security tests. Occasionally, at least once in a while, you may have a scenario where a product is trying to hit a release target date and needs to move forward. So this is why we have an exception procedure, and this is a critical part of the business so that a hot fix or important release is not caught in a loop and getting blocked due to a security finding that may not be a high risk. And so what does a security exception and risk approval process look like? Well, first, requires a mitigation plan and a timeline. And the timeline and plan should be relative to the risk and the severity. And requires approval documented in a system of record. So the official approval should be documented, and depending on the issue and level of severity, escalate up to the executive level to get that approval. This way, it's the line of business and the executive that owns the risk. The development team is not owning the risk. The SPOC doesn't own the risk. The business managers and the executives own the risk. And the most important point here is that we capture these approvals and mitigation plans in our system of record, in our engineering tooling. So in this case, we're using Jira to make sure that the approval is captured, but also that we enforce it with our automation system and orchestration, so that if we agree to fix something by December, and the engineering team is now trying to release in December and they haven't fixed that issue yet, then that will block the build, that'll block the release, and they will have they'll have to go back and resolve and meet their mitigation plan, or the project is blocked. And so that, again, is necessary when really we want to scale the risk acceptance program and achieve this at scale across 100, 150 products. You need to make sure that that decision is enforced in an automated fashion. And so now I'm going to wrap up here. Just to recap, we explored the foundations in the 3 key areas: culture, process, and governance. And I gave examples that you can take. Number 1, if you're just getting started and building a program, but also hopefully if you're looking to improve your AppSec program and improve your AppSec program to the next stage, some takeaways and actions you can take to go to the next level. So the advice and takeaways, again, begin where you are, focus on these foundations, set yourself up for success, and some questions to ask as you go along. What are the critical risks and objectives for your business? Start small, use iteration and minimum viable product, and that mindset to get things moving, establish some success, and build from there. So I hope you found something useful. Really would love to hear your feedback. Please let me know your thoughts. Where you can find me on social media, usually here, LinkedIn is the one I usually check. Shoot me a private message or mention me in a comment. Greatly appreciate any thoughts, comments, feedback, disagreements, complaints, arguments, anything at all. Just engage me and I'll be happy to discuss more and share additional details. Thank you very much.